Yeah, so moving on in this week, so what we do is NAT types. So we have different types of NAT. Following on, we have dynamic NAT, we have got static NAT, we have got dynamic path, static path, destination NAT, and something called as policy NAT. It is also called as twice NAT or manual NAT with ASA terms, but generally it is called as policy NAT. So this is something which is important to cover up. So I divide this session into couple of days, including other topic, right, so that you don't get too much burden with NAT, all the NATs in one day. That is really cumbersome. If you take 4 hours, at least 3.5 hours, 4 hours, then all the things could be done. But normally I do it till here. Dynamic NAT, static NAT, dynamic path, static path, configuration with explanation till a couple of hours. And next day we continue with destination NAT and policy NAT, along with this concept called as transparent firewall. So we'll see how to work with layer 2 firewalls. And after that, we normally talk about your virtualization and redundancy concepts quite a lot. So you learn about ASA, failover, context, interface redundancy, and all those things. And after that, we talk about deep packet inspection, which is also called as MPF, modular policy framework. And then we talk about the VPN implementations. Right. So I'm eyeing this week we will be touching till transparent firewall, and also we'll be touching the redundancy part. Okay. And the following week we talk about virtualization. We knock off that. We knock off deep packet inspection, and the following week we knock off VPN implementations. So okay, so moving on. So we talk about now the different types of NAT. So I believe you guys know what is NAT. Can anyone explain me what is NAT? It's a process by which edge device, whichever is configured with NAT, will translate basically the internal private IPs to public IP address. What is the reason why you do that? To allow the LAN users to reach internet, because by default, with your previous knowledge with routing switching, that private IPs are called as non-routable addresses. So using private IPs, you cannot reach to internet. They have to be NATed in order to translate the private IPs to a public IP, and the process is done by the edge device wherever you configure NAT. It could be done on a router, it could be done on a layer 3 switch, it could be done on a firewall. So the whole idea is we do it on the edge device. So we talk about the ASA, the ASA, NAT implementation and the way the NAT works on the ASA stuff. So following on, what we do is we first talk about what is dynamic NAT. So in dynamic NAT, if you think, what happens is, so let's say this is your LAN, right? This is your inside network. This is your LAN, and this is your outside network, which is your internet. Now, all the IPs that we have in the LAN, let us say this is all your private IPs. So let's say I take this example that I have got a pool of, core people sitting in 10.11.11.0/24 network, and they want to reach internet, right? So by default, without NATing, what is going to happen? Okay, you need to understand that first, and first you need to see, if I don't implement NAT, what is the problem and what will happen. Right? So let us say there is a data which a user generates at layer 7 of OSI model. Say this is an HTTP based traffic at layer 7. Then we encapsulate this with layer 4 So for HTTP or TCP protocol, will do the job of encapsulation. So TCP will have the source port number, the destination port number. Source port number is random. Say this is 4191. Destination port number for HTTP it is 80. Then you encapsulate at layer 3. You have the basic element of IPv4 header. You generally add all the parameters, but the important things is your source IP, destination IP over here. Source IP, say it is 10 dot. Let me take a little bit of space. So source IP and then destination IP. So source IP that we have here is 10.11.11. Say whatever, say 50, right? That is a source IP, and he wants to reach to internet. So say the global IP that he wants to reach is 200.111. Now this packet will also have layer 2 encapsulation with Ethernet header, source MAC, destination MAC, leave it. So now at the end of the day, this is the packet what the user generates, and this packet now has to travel from this device to its default gateway. So it goes to the default gateway. The default gateway does the routing table lookup, which is basically this firewall in our case, and the ASA should know, how to reach to internet resources. So the ASA should have a default route which should point towards the ISP, and likewise even this internal edge router, the inside edge router should also have a default route which points towards the firewall. Because if this internal users or internal router does not have this, or internal device does not have a default route pointed towards the firewall, the internet traffic cannot reach at all. So the ASA will have a default route towards the ISP, and based on that the routing will be done, the traffic will go to R2. And at this point of time I'm not implementing any NAT over here, but the traffic reaches R2, so it's an ISP router. What happens generally on the ISP router is they implement one solution called as URPF, that is unicast reverse path forwarding, right? It's a very common technology with the ISP stuff. So what happens when you enable URPF is when this particular packet, it enters or it comes as an ingress on the router interface, these routers will have a power to check the source IP of the packet first and decide that if this router has to reach the source IP address back, will they use the same interface or not? So if the source IP could be reached via the same interface where the packet arrived on, that means URPF is passed. So right now what will happen is this router, think about it, this router is an ISP router. He will normally have all the public routes known to him. This ISP router will generally not have any private networks to reach your company's LAN information or company's DMZ informations. So R2 will not have any route to reach your DMZ resources or internal resources at all. So when the packet arrives on E00 of this ISP router, it does an URPF check, looks for the source IP of the packet. It says 10.11.11.50, checks with his routing table. His routing table says, no, I don't have any IP address or any route to reach this IP address, right? And he drops the packet with the help of URPF. If it is not passed, it drops the packet. That is one thing. Along with URPF, what they also do is they write an ACL on the router, which blocks all your RFC 1918 addresses. So basically, they block all your private IP addresses. So when any packet arrives on it, right, and on the ACL, they already written that please block all private IP scopes. So if you come with a private IP address, if the ACL finds a match against your IP, it blocks the traffic. So at the end of the day, there is no way, you can reach to internet at all with this condition. Your packet will reach to the ISP router, but ISP router, the moment it receives an interface, it will drop it, right? First is URPF level. If not, it will go with the ACL level, whichever things is configured, it will drop the packet. Okay, that's the important stuff, why NAT is really, really crucial, right? Why NAT is really, really crucial. So NAT, you need to enable this on this, let us say on the edge firewall over here. Once you do that, let us say you have done, there are different types of NAT as I've told you. Let us say you are trying to implement dynamic NAT. So dynamic NAT, what will happen is you create something called as a pool, right? In the pool, you normally keep your public IP scope over here. So think your company is rich, so it has got, let us say, abundant public IPs in the pool to allow all these companies inside resources to reach to internet using those abundant public IPs. So say in the public IP pool that we need to create, the company has this public IPs with it, 192.1.20.50 to 192.1.20. say 190. Imagine, just for a fun. So I've got roughly 140, 150 IP addresses in the pool. That means I can allow simultaneously, right, at same point of time, I can allow 150 users from inside to reach to internet, for an example, right? So now what happens is when this particular packet, let us say I've enabled NAT and I've created the pool, right? Now, once the pool is created, what you do is you create a NAT profile. The NAT profile you call the source address. The source address is, as of now, the users of 10.11.11.0/24 network. So basically, these users are there as a NAT source, and you link this NAT source with the pool. So whenever any IP addresses from this source tries to reach to internet, the ASA would do what? It will allow the private IP to pick one IP address, or the ASA will basically translate the private IP to one of the public IP from the pool, and the traffic will go outside. So this job of translation would be done by the ASA once the ASA knows that the routing is there. So the ASA would check for his routing table. The routing table, if he finds that there is a route to reach the destination IP, then if the ASA is configured with NAT, then he will do the NAT action. So the NAT, what it does is it will translate the source of the packet, right, to a public IP from the pool that is available in the pool. So now every contents will remain the same in the ASA. When the traffic reaches from the ASA, everything will remain the same. So this, the layer 7 is same, your layer 4 entry is same, right? What will be translated is this guy is translated to, the source IP is translated to, let us say one of the IP of the pool, say it is 192.1.20.57, right? So this is the IP address that has been translated to 10.11.11.50, and the destination remains the same, right? So the destination is still 200.1.1.1. That's the ASA's job. It translates the source IP of the packet and then lets the packet go out following the routing table, right? The moment it does this, the ASA does one more job, is it creates a table called as a translation table. It creates a table called as a translation table, also known as your XLET table, also called as your XLET table. So the translation table, what it does is it keeps a mapping that I have translated this 10.11.11.50 to 192.1.20.57 when the packet was trying to leave out. All right. Now the packet leaves out. So what R2 gets? So R2 is getting an IP. It is getting a packet from a source IP which is 192.1.20.57. Right. So if it does a URPF check, it says that, yeah, I know this network because it is connected via E00. So URPF check will be passed, and if it goes to the next level of ACL processing, so ACL is blocking your private IPs, and now it is not a private IP, it is all public IP. So ACL will allow the traffic as well. After that, the destination IP is looked by the ISP router, and ISP router says to reach 200.1.1.1, I have a BGP route generally ISPs runs BGP to reach internet networks, and based on that, the destination, the packet is delivered towards the right destination following the BGP entries. Now what the packet returns back, right? The packet returns back. So remember one thing, say it is HTTP traffic, it is a TCP traffic. Along with your translation table, you also have the connection table, because the traffic is going from high security level to low security level. You'll also have the connection table built up, and the connection table will also keep the real IP, not the translated IP. So connection table will keep the return entry for the private IP. So it will say that I will allow the traffic from 200.111 to reach back to 10.11.11.50. So that is there in the connection table. Okay. So now what happens here? When the reply traffic comes back from the internet, the return traffic, when it comes back from the internet, right, how it looks like. So it looks like, everything will remain the same. The HTTP response, it will come from source IP and the destination IP. So source IP will be your 200.1.1.1 and destination IP would be your 192.1.20.57. So the internet is trying to give a reply to this guy. When the packet comes to the router says, yeah, so to reach this guy, my next hop is, or I should throw the packet via E00. The packet is routed towards the firewall back. Now, once the ASA receives it, the ASA first thing it looks for what? It looks for your NAT. So the first thing that the ASA will do is, I'm enabled with NAT, so I will do NAT first. So in the NAT, first it will do what? It checks this, X-leg table, and it will ensure that, this source IP would be retranslated or untranslated back to the, not this one. It will actually translate, this will be 200.1.1.1, and this will be translated back to the original ones, which is 10.11.11.50. Once the traffic is retranslated by the firewall, it goes and checks your, connection table, right? Connection table will say, yep, I see a connection table with me, which says, 200.1.1.1 if it tries to reach 10.11.11.50. So I have a connection table entry with me right here. So, yep, this traffic is allowed, in the connection table. So if there is a traffic entry in the connection table, what connection table does is, it does not need ACL. It does not look for what? What is that? Security level. It checks for the routing table after this, and the traffic comes back to the inside network. So at the end of the day, what you have done is, while sending the traffic from inside to outside, right, you have sent the traffic from inside to outside by doing the NAT process, which will translate the source IP of the packet. And likewise, when the traffic returns from the internet to inside, you have translated the destination IP of the packet back to the original one, and then the traffic entered your network. So that is clear. In the world of ASA, careful to my words now. In the world of ASA, there is two concepts. One is called as source NAT, and one is called as destination NAT. Right? Source NAT and destination NAT. So check out here. When the traffic was leaving from inside to outside, you translated the source IP of the packet, right? Do you agree? When the traffic returned from the outside to inside, you translated what? The destination IP of the packet, right? Concentrate, please. When the traffic was leaving from inside to outside, we changed what? The source IP of the packet, right? When the traffic was returning from outside to inside, we changed what? The destination IP of the packet. So will I call this as source NAT when the traffic was leaving from inside to outside? And will I call this as a destination NAT when the traffic is coming in from outside to inside? Is my sentence correct? This concept is treated differently by different firewalls. Okay? With respect to ASA, you need to understand this. With respect to ASA, everything, 99.9% is what? Is source NAT. 0.1%, very rare case, 0.1% is your Now, what do I mean? Source NAT, see, when the traffic was leaving from inside to outside, you translated whose IP? Let me just remove everything, okay? I'm just removing everything, guys, yeah? Let me just clear everything. So when the traffic was leaving from inside to outside, you translated which IP address? 10.11.11.50 got translated to what? 192.1.20.57. That's it. Right? So basically, this was the real source IP, and this was the real destination IP, which was going to where? 200.1.1.1. When the traffic was leaving, you did this job. When the traffic was returning, what happened? Was the source now? 200.1.1.1. Destination was what? And in this case, you have translated which one? This was my source, this was my destination. In this case, this was my source, this was my destination, correct? In this case, you have translated this guy back to what? 10.11.11.50. In both the cases, you have translated whose IP address? Your IP or the remote IP? For this condition, you need to understand this. For this condition, what is your IP? Your IP is your internal IP, right? 10.11.11 network is your IP. And the remote IP is what? Facebook.com, Google.com, anything in the public, right? That is a remote IP. When the traffic was leaving from inside to outside, did you translate your IP or did you translate the remote IP? Your local IP, correct? Similarly, when the same traffic, when it was returning back, you translated whose IP? Your IP only, right? In both the directions, you translated local IP. You have never translated the remote IP. So since you translate this 99.99%, right? This concept is called as what? In case of ASA. Palo Alto takes in a different angle. We'll talk about this later. What Palo Alto thinks, you know what? Simple story. When the traffic was leaving, the previous one that I've explained to you, when it was going from inside to outside, that is source NAT. Rather returning back, it is destination NAT. Right? So Palo Alto thinks it is in the other way around. Because you are changing the source IP of the packet, that is source NAT. You are changing the destination IP of the packet, that is destination NAT. With respect to Palo Alto. But with respect to ASA, you need to understand that it is always what? You are actually representing the DMZ servers publicly outside with a netted IP, isn't it? You are representing a DMZ server publicly outside with a netted IP. That means you are representing your IP only outside. That means you are translating whose address? Remote or yours, local. In that case, everything is called as what? Source NAT. But there is one chance that 0.1%, we call this as destination NAT. I will teach that on the next day. That time we'll understand what is the real meaning of it with respect to ASA. Okay? Clear? So if that is the case, what is the first thing we do in dynamic NAT? First thing, we create a pool, write the public IP range there. Next, we create the source. We call the source with your internal IP there. That needs to be natted, and then we link this things with the pool. Right? So let's keep the thing going. Dynamic NAT. It is used to translate the internal users to a dynamic pool of public IP and allowed to reach internet. Syntax that we use in case of AS, you need to understand this. syntax we use. So there are a couple of steps. So step 1 is to create the pool, create the public pool. So syntax is you create like that, called as object network. Everything in case of natting with firewalls, it is like based on objects. Okay, so we create something called as object network, and then you define something called as a pool name, whatever name, meaningful name you define there, and then you define the public IP scope with the range command, and then you define the start IP, then you define the end IP, right? And in step number 2, you define the internal network which needs to be natted. So for that, what you do is the syntax is this: object network, give a name, a meaningful name, and then you use the keyword called as subnet, and then you use the keyword called as network followed by the keyword which is mask of that network. You call the internal network over here, and then you use the command called as NAT to link the internal network with the pool. So NAT, then you start with a command, or the syntax is like that: high interface name, okay, then comma low interface name. So basically it is respected to security level. So high interface name is your inside, low interface name would be outside, followed by the keyword dynamic to go for dynamic NAT, and then link the pool name over here, right? So in ASA 9.series we do it in this way. So if I give you a task right now, task for dynamic NAT, so I'm saying allow the inside network, say 10.11.11.0/24, to use the pool, say my pool, which has got a range of 192.1.20. say 100 to 192.1.20. say 200, with the help of dynamic NAT. So I'm going to allow the inside network this to use the pool, my pool, with the help of dynamic NAT to reach internet. So to do that, what's my solution? So first I will create the range. So command is object network, syntax is right on top, define a pool name, whatever. So as for the objective, it is my pool, and then I use the command range, and I say 192.1.20.100, 192.1.20.200, that's my range, right? And then I create the internal network that has to be used. So I say object network, whatever, say I give the name as uppercase, let's say this is my name, so this is my inside network as a name, and then I say subnet, which is 10.11.11.0 followed by the mask, and then I define the command NAT in bracket. In bracket I define the high interface name, so it is inside, that's the name of the ports, and then I go with outside, and then use the command dynamic, and then design the pool name, which is my pool. Okay, make sure this pool name is case sensitive. All right, so this is the thing that you will do. But before I apply this natting and all, we need to understand the topology as well. So what I've done so far is I've configured the IP addresses on all the routers, including the ASA. So everybody has the connected routes. Now what I want is, I want the ASA and the ISP will not have any sort of routing protocol between them. The ASA will only use a default route to reach towards the internet network, and the ASA will run OSPF with the DMZs, and say the ASA will run OSPF with the LAN to do internal routing, and R2 will not have any route known to us. Okay, because R2 is an ISP router. He will not have any route which is reaching back to us. So thinking about that, so let's enable OSPF one by one. So R1, it's router OSPF1, router ID, network. I want to enable on all my 10.series, and here it is wildcard mask in area 0. That's it. On R3, OSPF1, router ID, network, it is 10.3 and 192.168.3.0. R4, to 168 4.0 and 10.440. Done. And the ASA will have a OSPF towards us and a default route towards internet. So on the ASA, I say router OSPF 1, I define router ID, say it is 100, and network, so skipping 192, so it is 192.168. I'm skipping the outside, it is 3.0. In case of ASA, it is subnet mask and area 0, 4.0, and 10.11.11.0. Done with this. So if I see show OSPF neighbors, I have 3 neighbors, couple of DMZ and 1 inside. And if I see show route OSPF, I'll have all the routes of my inside and the DMZs known to me. And one more thing I should do is I should also have, so route outside 00 192.1.20.2. So if I see here show route static, I have a default route via my next hop. And also one more thing is, if this DMZ routers and this inside router, if they get the packet to reach internet, I mean, even they should also have what? Even this router should also have what? Default route. Even they should also have default route, because they will not have the route known. So going to R1, configure the default route via my firewall for the inside router. Similarly for R3, I'm configuring a default route towards 192.168.3.10, and likewise at R4, I'll configure a default route via 192.168.4.10. So all my inside DMZ and the inside DMZ and the firewall, they have a default route towards the internet. And R2, if you look closely, R2 don't have anything else apart from its connected routes, which is generally representing as the public networks. So all the networks that it has, they're all public networks represented like that, and they don't have any route reaching back to us. So at this stage, I've enabled telnet on all the routers. Okay. So if I go to R1 and try to telnet R2, will it happen? So I go to R1 and try to telnet which one? 199.111. Will it happen? So basically, we are taking the private IP of the packet. So the source IP will be taken as 10.11.11.1. The traffic will go with the private IP, and R2 don't have a route reaching back to us. So this will never work out. The packet is going towards the ISP router for sure, but he will drop it since there is no route reaching back to us. Alright, so now this will not happen at all until and unless we enable the NAT process. So let's go there, enable NAT, commands are ready, made my pool, made my inside network. To use the pool, dynamic NAT it is, copied it, going to the firewall, global config mode, apply the NAT. Right, made the range, made the inside network to use the dynamic pool. Now once you're done with that, the one command that you can type is called as show xlate first to see the NAT translation table. If any users are getting translated, the table will be created here, and the table to verify show xlate. And next is show NAT detail. So you can see show NAT detail. You can see what type of NAT you have configured. So you can see there is a NAT. By the way, the dynamic NATs are called as auto NAT policies. Okay, dynamic NAT are called as auto NAT or object NAT. So you see that there is a NAT for inside to outside that will be using, this is the object, source object, this is the pool object, and basically you are translating this source to this pool of private IPs to this pool of public IPs. All right, so now to verify back, I go to R1. I do the same job, telnet 199.111. Last time it was not happening. You know the reason. Now it will happen because I'll be translating with the public IP. Password, give the password. If you see show users, so generally 10.11.11.1 has tried to access, but this will be NATed. And now see, this user has taken a public IP of the pool randomly, and it went out. And at this stage, if I go to my ASA and verify show xlate, I can see the translation table, which says 10.11.11.1. When he was trying to reach internet through the outside port, he was translated to this particular IP. And if you see show con, there is the show connection table. Connection table will keep your original IPs. So see that connection table says that I will allow the return packet from 199.111 if it is coming from port number 23 to this destination 10.11.11.1. Okay, so go behind my explanation and try to understand that. All right, so now this is happening and we are good to go. Can I ping 199.111? From R1. To allow this, we need what? Explicit ACL. So as of now, no ACL is configured. That is the reason the pings will not work. The traffic will be NATed, it will go out, everything is fine. So what is happening here is this logic. When the traffic went out here, there's no problem at all. The traffic, when it is returning, right? So it was NATed, by the way. So the traffic returns back, you first do the NAT, and then you look for what? Connection table. You don't have an entry in the connection table, then you look for what?
ACL.
ACL. You don't have an ACL, you're blocked. Security level will not block it, ACL will block it. If there is a connection table entry, it will bypass the ACL, it will bypass the security level, check the routing table, come in. Okay. Done with this.